Welcome back to the lecture number 9 of this course. So today we will be talk about the room database. Last week we talked about the database using the SQLite, how you can directly communicate with the SQLite rather than using the room architecture which is provided by the Android in 2019. So what is the purpose of this room? It is an abstraction layer of the SQLite. If you remember in the last lecture, we have written down the queries, inserting the tables, creating the database, inserting different rows in the table, updating the table. We have to write all those queries, and then we are able to communicate and do the things inside the SQLite. But if we use the room architecture, then all those queries, except the select queries, they are all abstracted and we don't need to write them. We don't need to create the database. We don't need to write the queries to insert the information or update the information or delete some information from the table. So that is an abstraction layer that provide you an abstract way to do the things, to make things easier for us, the people who don't know much about the SQL language. So allowed fluent database access. And the other thing is, in that case, we have a cursor. Remember that when we are reading the information from the database is returned back a cursor, and then we need to move to the first record and read that record and check the informations and read all those information inside the string or whatever you want. But again, that is also is more convenient, more simpler, that we creating a database based on our classes, and that classes are going to receive the data inside them. If it is more than one record, then it will automatically give us the list of those classes, and then we don't just need to access those class objects or the properties or the attributes inside that one. So that makes things quite easier, and you will see that, yeah, in a few in the next slides, in the next few slides. So cache relevant pieces of the data without network. App provides contents from the local database. Uh, Cache mean that, I mean, if we have something which is the services which is more based on the cloud and the remote data, then we can have relevant information stored inside our local database, and we can serve in case the internet connection is not available. So that is also the purpose of the database, whether we are using the SQLite directly or we are using the room architecture. Changes synced data to the server when the application is backlogged. I mean, if your data has changed locally within your mobile, then whenever you get the network connection, then you can update those information on the server side. So room takes care of these concerns for you. Okay, so room will help you to understand, I mean, take care of all these concerns. Okay, so the first thing, we have the components of the database component of the room architecture. The first is a database. It's a class which is annotated with the add date of database. And what do you mean by annotation? Annotation is more like you are telling this particular specific class, whatever the name of that class is, you are telling that this is representing my database. Okay, so it is an abstract class that extends to room database, and it will be more clear when you see the example that what do you mean by the annotation at the date of database. Include the list of the entities associated with the database. Entities is are again, these are the classes that you have defined, and they are actually become the table inside your your database. So also has an abstract method with zero arguments, no argument at all, and it will return you a class, or we are, I would say, rather than interface, which is annotated with DAO, data access objects. And what is that, I will be discussing in the next few slides. Again, the first thing, we can create the instance of our database in two different ways. There are two different constructors, there are two different builders for our database. One is a database builder which take three parameters: context, the context of the application for which this database is being created. Second, the name of the class, the class that you have created with the annotation at the rate of database, that is the name of the class that it is going to accept, and what will be the name of the database itself. So it will look at the context. I am going to create a database with that specific name using the class for that particular specific mobile application. So that are the three parameters. So it will be a permanent storage. It will be stored inside your mobile application, inside not in the mobile, inside your mobile, permanently stored. And then we also have a second way to create a database, that is in-memory database builder. In-memory database builder mean that it will only take the context that this particular specific database is created for that particular specific application, and which class has defined all those entities, what are the different tables and that kind of stuff. So in-memory database is more like a database which is only present inside the RAM, random access memory. So it is only per memory. So whenever your application is going to turn off, or it will be destroyed by the Android system to make some room for the other applications to run, then this particular specific database which is in memory will be lost. So we need to understand what exactly are the needs of our database for our application, whether we want to save those information permanently inside our permanent memory or the hard disk, you can say that in the computer terms, or we only want that particular specific database inside the memory. So we have two different methods, and inside the memory we don't need to provide the name of that particular specific database. So these are the two ways to create the room architect or database for the room. Entity is actually a class that represents a table within the database. Entity, a class that you have defined which represents a database inside the table. DAO contains the methods. Don't worry about that entity. What does it exactly mean? When you look at the examples, it will be much more clear. Okay. So DAO again contains the method used for accessing the database. What exactly it is more like an interface which is annotated with at the rate of DAO, and in which you can define the signatures or the headers of your methods that will be going to access the data or save the data or update the data from your database, and they are not going to be implemented by you, rather they will be implemented by the room architecture automatically. So this is our room architecture. We have a room database, data access objects, and the data entities and the rest of the application. So we have a database object, which is a database class with the annotation at the rate of database. We also have data access objects which help you to communicate with the database itself inside your applications, and entities are representing the structure or the schema or the design of your database. So defining the entities, first of all we need to define the database structure in terms of the entities. Okay, so first of all we need to create the entities. Entity is a Java class which is annotated with the entity. So this is an example of the entity. So what we are saying, we have a public class student in which we have some parameters, some features, or some attributes. For example, the private int student ID, private string first name, private string last name, and private data date DOB or database. And then we also provide at the top of that particular specific, above that particular class, when we define public class student, we are saying that this is an entity, and telling that the name of the table that is going, where the student class values or the informations are going to be stored, that name will be the students. So what this particular entity mean, the DO or the room architecture will create a database table with the name students, and inside that particular specific students table it will have four different columns. One is the SID, that is the student ID, which is representing the student ID of the integer type, and we are also telling that this is the primary key of this particular specific table, because we have annotated this attribute or this field with the add date of primary key. So SID, exact same spelling, that will be created in the table, okay, and that will be marked as a primary key for that particular specific table. The second thing we are saying that is a private string's first name, and then we are saying column info. It is also a column, it is also represents a column inside the students table, but now here we are saying that the name of that column should be the first underscore name rather than the name of the variable that you are declaring as a string here. So here we don't put the column information, so that's why it will take the name of the variable, and exactly the same column name will be created inside the students table. But here we are saying that don't use the first name, uh, that the name of the variable, rather than use first underscore name as the name of the column inside the table, inside the database table. The same thing we are doing for the last name and the date of birth. Okay, so rather than using the name of the variables as the name of the columns, we are providing them the different names. We can do the same thing for the uh, like our primary key as well. We can also have, like, just after the primary key we put an enter, and then you say add the date of column info, and it will provide that. So table name, entity, you can specify the table name. If you don't specify the table name, you just say add the date of entity, then whatever the class name will be, that will be become the table or name of the database. Primary key, you know that what is a primary key. Primary key is a column which whose values, which value, I mean, whose values cannot be null. We cannot provide I mean, we have to provide the value for that particular specific column, and they are indexed. Indexed mean that if we want to search some records from that particular specific table, then we can quickly find them. We have the indexing, so primary key is automatically indexed. Composite primary key, we can also have like multiple columns as a primary key, so that is called composite primary key. If you want to define that thing, then you have to define at the table level, when you are where you are defining that it is an entity and table name, then primary keys, and then you can provide name of those columns or name of those variables. So that is where you can see that you can create the composite key, whether you are having only one field which is a primary key, you can define it like this, and if you have a primary key which is more composite, then you can provide like this at the table level. We can also say that at the rate of primary key auto generate mean it will be like SID value. You don't need to provide that SID value, it will automatically become 1 2 3 4 5 6 7 8 9. So it will be auto generated by the system itself, about the androids, about by the database. So you don't need to worry about to provide that particular specific ID and making it a unique value inside a table and so on. We also have the column info. Column info help us to override a few things that I have explained you. The name of the column, if you don't provide this particular specific line, the column info, then whatever the variable name will be, that will become the name of the column inside the database. But if you want to override, you can provide that particular specific at the rate of column info. If you want more information, you click on that particular link and it will take you to that annotation, and then you can see that what you can define at the column level, what type of information that you can override. Index, again, indexing and uniqueness. So index certain fields to be sped up by the query. So indexes actually help us to search the data quickly rather than looking at the whole table. For example, if we have a table with the 10,000 or maybe 1 million or 10 million entries, then searching something from that which is not indexed, then it will be take a very long time rather than finding that particular record quickly. So indexes help us to query or to search the information quickly from our data table or database where the data is very large. So indices properties within the entity. Again, we can define the indices at the table level inside the add the date of entity annotation, and we can also unique, that's a uniqueness property. It means that that particular specific column values will be unique. For example, if you say the last name should be unique, Then if you have a student name, Alice Wonder or Alice, what you can, okay, I can give you my name, Abbas Malik. So Malik is the uh, last name, and if I say that the last name should be unique, then I cannot enter another student in the, or another person in that particular specific table which has the last name Malik. So unique, like in that particular specific column, all the values will be unique, and that is true for our and primary key. In the primary key, number one thing, we have to provide the value. It means it cannot be a null value. We cannot supply a null value for the primary key. Number two, it will be a unique value. And then number three, the index will be automatically created for the primary key. So based on the primary key, we can quickly search our record inside our database tables, whether the data inside that particular specific table is large or small. So index and the uniqueness. So we can define the indexes. For example, we are saying the at the rate of name. We are saying that the first name and last name values, we say unique is equal to true. The first name and last name values should be unique. We cannot have two students with the same name, Abbas Malik, Abbas Malik. No, that's not possible. So if we want, we need to like provide some a different way. Then you have to say that it can be a unique is equal to false, so it cannot be unique. Relationship between the tables, remember that we have a foreign key primary key relationship. So SQLite is a relational database, that's true. And then the foreign key constraints between the entities add the rate of foreign key annotation and properties for the foreign key. So we need to define, we can define the parent child relationship using that particular specific add the rate of foreign key. So what we are saying that we have courses and we have some students. So some course, one particular specific student can study multiple courses. So what we are saying that here, so we have a course ID, we have a course name, and then we say that student ID. So student ID is more like a foreign key for that particular specific table, and here we can define it. Add the rate of entity, foreign keys is equal to add the rate of foreign key, and we say entity is equal to student.class. Student.class is the parent table. Parent table mean that the value of that specific STID, student ID, cannot be there unless and until they are not present inside the student table. If the student ID exists in the students table, then it can come down here, otherwise it cannot be. So that is a parent class. And then we are saying that what is the parent column. And if you remember, if you go back to our student ID here, yeah, so it is an SID, the name of the column. So we are providing that name here as a parent column. Okay, and then we are saying that the child column is actually this one, that is a student ID that we have defined in the add rate of column info. So what does that mean? That in this table of the course, we cannot have a student ID which is not present in the students table. Okay, so that is the purpose of the foreign key. So that relationship we can define in the form of the foreign keys is equal to add rate of foreign key. So that is how we can define the relationship between different tables. Nested objects, for example, we have address which contain the street address, we contain the region, which contain the city, and which also contain the postcode. So we have a street, state, city, and postcode. That is the one, what you can say that address information of a student. So we can embed those information inside the students table like this. So we say public, create the object of this class, public address inside our students table or students class, and we say add the rate of embedded. It means it now automatically the street, state, city, and the postcode columns are going to be added inside the students table. Okay, so that is called embedding. In this way you can have the columns name, street, state, and city, and postcode inside the students table, but still you can access them in the form of the address. So we can say address.get address, address.street, address.state, address.city, address dot postcode. So we are like combining the similar kind of information in one object, yet they are representing the multiple columns inside the table itself. So these are the nested objects that we can use to group. Nested objects are more like grouping the same kind of information. For example, name may be divided into the first name, middle name, and last name. So it has three different properties, and we can say that we have a name class in which you define those attributes, and then you embed that inside the employee class or the student class or so on. Okay, so in this way we can group the same kind of information in one particular specific object that we can use later on inside our code. We also have the data access object, that's DAO method. We define the methods, abstract class method, abstract class to database, either an interface or an abstract class. So mostly we are defining it as an interface rather than the abstract class, but yes, we can define in the abstract class if you have some more information. If it is an abstract class, it can optionally have a constructor that takes a room database as its only parameter. Okay, if it is an abstract class, then you can have a constructor which can takes a one room database as its only parameter. So defining the DAO, insert at the rate of insert annotation. So insert values in the database. So when you say at the rate of insert, when you are defining a specific method, it means that this particular specific method is going to insert some information in some specific database based on the info, the parameter that you are passing. If you are passing the course parameter, it will go and add those information inside the courses table or the course table. And if you are passing a object of the student, then it will automatically go and pass that particular, add that particular specific information inside the student table. So based on the parameter, it will decide that which table it is going to insert that the information. So its implementation, we are only giving the definition, or what you can say that the header or the defining the header information. We see that what is the parameter, what is the return type, what is the name of that method, and what will be the parameters. We are not going to give the body is going to be generated, or the implementation is going to be generated automatically by the room system. Okay, so we are going to provide something like this. So we are say add the date of insert, we are going to insert some information, and because we are passing as a student as an object, so it will say that we are going to insert inside the student based on the information which are present in that particular parameter, and it is not going to return me anything, and this is the name of the method. Similarly, we can also have the other way to insert. For example, if we are passing the multiple objects, student 1, student 2, student 3, array of the, or the list of the students, then we can pass, and they will be added inside the students table. So it does not return anything, and we are saying add the date of insert on conflict. Due to some errors, you are giving the information which are, there's a conflict. For example, you already have given the student id 1, and you give the student id 1 again. So what will happen now? There's a conflict between the insert operation. So what will happen? So the new value will be replaced. So we are passing that if there's a conflict occur during the insert, by default it will not insert the new record and raise an SQL exception. But if you don't want to raise that exception, then you can say on conflict what you want to replace, or you can also have some other ways to do it. But here I say that you can replace that, the new old values will be replaced with the new value. We can also have like two different objects and insert two students. So we have different way, and now we are only passing the header of that particular specific method. We are not giving how it's going to be implemented. We are not writing the insert queries and which table and so on. So that will be handled automatically by the room architecture. Similarly, we also have the update. So update is, again, we are saying that update all students. We are providing a list of students, and then we say that at the date of update, we are updating the information. On conflict, replace. If there is a conflict in the information, then replace with the new values. Similarly, we have other ways, one student or two students we can update, delete, I mean remove a set of entities. So we are say add the rate of delete, we are deleting based on the student IDs. That's our primary key. So it will search those records with that particular specific student ID which are present in those students objects and delete that particular specific rows. So can return an integer value, number of rows deleted. So this particular specific delete method can return an integer value which representing the number of rows are deleted. And the other thing is, if we look at the add the rate of update or insert, they can also return me the long values. Insert and update can return the long or the array of long values which are representing the in terms of update which specific record with this specific primary key ID has been updated. So it will return, if it's only one student, then it will return that particular specific row ID as a long value. And if they are multiple, then it will return me the IDs in the form of a array of the long. So we can return some values as well. You can see these annotations, details, documentation on the web, and then you will find out more information about that. Again, we also have the add the rate of query annotation, main annotation used in the DAO. This is like accessing the data, reading the data, perform read and write operations on the database. So add the rate of query is the only place where we need to write some queries. The good thing about that particular specific add the rate of query and the DAO and the room architecture is that these particular specific queries are being validated and checked at the compile time rather than at the run time. So if you are, when you are writing the code and if you are like compiling them, if there is a mistake in your query, they will be uh, highlighted to you at the compile time rather than at the runtime. So we can have some like add the rate of query. Here we say select static, select all the columns from the students table, and then it will return me a list of the students. Similarly, we say that select all the columns from the students where the SID in where SID in that particular specific. So actually we are providing us um, an array of integers which are representing the students IDs, and then we are telling that all the student ID which are present in that particular specific array, check in that students table. If they exist in the table, then return me all those students with that particular specific students IDs. So this is the only place where we need to write some queries, otherwise we don't need to write any kind of a query in the room architecture. Again, based on this first name and the last name, we are trying to find out the student. So it will take only one. Limit is equal to 1 mean that it is going to give me only one record as an output. This is a sample application, but we will be developing a different one. So first of all, when we want to see, the first thing is we need to update, we need to put that particular specific Gradle information, the dependencies of the room architecture, we need to add those inside our the Gradle file. So these are the information. So we are defining a room version, this is 1.1.1, and then we are implementing, we are telling that room architecture and the testing things. So we need to add those lines inside our Gradle file, build.gradle file, so that the room dependencies has been added inside our project. Second thing is we need to create the entities, and the third thing is we need to create the DAO, data access objects, and the third step is we create the database. So first thing is we are creating the database design. We are providing the table definition in terms of a class with the annotations, of course. And then we are providing the DAO, how we are going to communicate with that particular specific table that we have defined in the entity. So how we can insert the information, how we can update the information, how we can delete the information, and how we can read the information from that particular specific student table. And the third thing is we need to create that particular specific database. Again, add the date of database, we are telling the public abstract class students table student database. So we are saying add the rate of entities, Add edit of database, so it's a database class. For the room architecture, we are defining the entities, so we have only one class, that is a student dot class. So if we have multiple, then we can put a comma and give the more values. What is the version name of the version of the that particular specific table or database? We want to export schema, yes or no? Normally we will take it false. We don't want to export that particular specific schema, and it extend that particular specific apps class. Abstract class will be a child of the room database. And here we are going to define two public static student database. So that's a static mean that we, because it is an abstract class, we cannot create its objects. If we want to access that student's database, then it should be static, so that we can access that by providing the student database dot student database name. And in the beginning we are making it null value. We also have an abstract method, public abstract student DAO. It return me the DAO objects, public interface student DAO. It return as DAO object, and it does not take any input. And the name of the, or we can, I mean, this is the name of the method. You can give any, create student DAO, create my DAO, whatever name you want to provide it here. And then in where we have a public static student database, it is going to return me a student database and get instance. So we are getting the instance. So again, that's the name of the method here. So you can create a method, create an instance, create a database, create my student database, whatever you want to give it here. You can provide that name of the student. So but it will return me the same name of that particular the object of that particular specific class, which is a static object. And it is going, we are providing the context, the application context, and then we are checking that if this particular specific static student table database object is null, then we are going to create it. And then how we can create it? Student database is equal to room dot database builder. Remember that we have that particular, we talk about, we have two different database builders inside the room. The one is the database builder, the other is in memory database builder. Okay, so here we are creating using the database builder. First we are providing the context, the application context, which is coming from our activity. And then we are providing the student database dot class. So that is the name of the class which is representing the database itself, which is this one, the same class that where in which we are right now. And then we are providing the student tab, I mean database name, that as a string. That name again, my DB, my first DB, my test DB, student database test, D03 course test, whatever you want to give it a name. Okay, and then we are saying that actually we say dot build, it will create that particular specific database table, database for us, and assign it its value to the student database here. It will not remain null once we have executed this method. And what about this one, dot allow main thread queries? Starting from the version, what you can say that the Android version 4.4, they have say that you cannot in the main activity, because they, this is the user interaction that's happening in the main activities or the activity classes. So if you are running some specific network operations or the database operations, may those, it is possible that those operations can take a long time. And if that operations are taking a long time, then your activity or your user interface will become irresponsive to the user. So starting from the version Android version 4, don't remember the exactly the name, the KitKat. So they have stopped, they have said that no, you can't use the database operation, you can't run the database operations within the activity. So by default it is forbidden, but you can allow, because we have a very small database, we are testing it. So we say dot main thread queries dot allow, we are allowing our main thread queries, or allowing our activity class to run some database operation. If we don't allow, then you have to create the new threads and pass those particular specific database operations to those threads to execute and return back the answers. So to make our life a bit easier, we are saying that we allow the main activity to execute or to perform those database operations on the main activity. And at the end, of course, we are returning that particular specific student database object. So this is our database class. So creating the database, so we say public static student DAO. Inside our main activity, we create that particular specific DAO object, and then we say student DAO because we need a DAO to perform or to execute all those insert, update, read operations. So we say that student DAO is equal to student database. That's the name of the class, and because this method is static, so we don't need to create the object of that class. We can just say that name of that class dot get instance dot create instance dot create db, whatever name you have given over there, and then we say main activity dot this, or we can simply say this as well, that is giving the context, and then we are accessing that particular student DAO. That is the this method. So first we are creating this method which return me the object of this particular specific class, and using that object we are saying that we are executing student DAO abstract method, and that will return me a student DAO object, and that is what we are doing here. First, go into that particular class, run the get instance method. If the database object is null, create it and return it. Once it is returned, so this particular specific part will have the database object, and from that database object we are running the student DAO or create student DAO abstract method, which will return us the student DAO object, which we are saving inside that student DAO. And then from that student DAO, that's the data access object, we can run all the methods that we have defined here. uh, get all, get by last name, get by username, get insert the student, insert student, update students, delete student. So using that particular specific DA object, we can call all those objects or call all those methods and communicate with our database. So async task is again it is more like here we are say that allow main thread queries. If we don't allow, if we don't have that line here, only say bracket close dot build, then it means that main thread query we cannot run the database operations inside our activities classes. So for that we need the what you can say that async tasks. These are the way how you can thread the information, how you can create a new thread and pass on some specific actions to it, and it will return back. So this is a class, private class, network site access, or what you can say that read students data. That's the name of the class. You can give any. It should be a child class of the async task, and it provide three information. The first one is the inputs for the starting thread. The second one is the progress reporting for the threading. I mean, how much progress you have made in that particular specific, how much data. For example, if we are reading the 1 billion records, then how many records we have read at one specific time, and then maybe we can show the progress bar or something like that to the student, to our users, to update him about that particular specific completion of that task. And at the end, what will be the return type of that one. So all these should be of the class type values. Okay, URL, string and string. So the method of override, so we need to override a method, so do in background, so it must be written, overridden. That is where you are actually performing that particular specific database operation. So should protected string do in the background, whatever the parameters are you have defined here, they will be passed as a list of those things will be passed as a parameter to this method, and then it will execute, it will perform that function that you want to be done inside the thread, inside a separate thread than the main one. So you perform that one, and at the end you can On pre-execute mean that if before you can run that do in background method, if you want to perform, you can do some parameters, you can do some initialization of the variables and so on, you can do it in the on pre-execute. And we also have the on progress update. Again, this is the only method, the first one, do in background, that you need to override. You need to tell that what you want to do in that particular specific thread. These methods are not compulsory to be override, but yes, if you want to have some specific reasoning, specific requirement, then you can. On pre-execute mean that before you can run this thing, if you want some initialize some variables in that class, you can do it in the pre-execute. On progress update mean that whenever you are completing, for example, after every 5% we are reporting the progress, then you can on progress update whenever specific values are done, so you can update the information inside the progress bar or something. And the last method is called the on post execute. On post execute mean that you are going to once that particular specific operation that you want to perform in that thread has completed, then you can execute that particular on post execute, and that will help you to report back the results to the activity. And then if the activity want to show that results to the user, then the user can show it. So reading from the URL, so actually let me I will give you the example of this one, but the point is async task now has been deprecated in the API level 30, which has been recently updated by the in the Android 11. They have deprecated, they have, like, they say that this is class is not up to the performance requirement of the Android system, so they are going to introduce, right now they have not introduced any new class instead of this one. So what we need to do, we need to stick to our Java basic multi-threading architecture, and then we can perform. We can still use the async task. In the practical demo I will show you how we can do that, but definitely this is not recommended now that you use the async task. We have to stick to the Java multi-threading options, the basic ones, so that to avoid in future this particular specific class will be removed from the API. And if your application is using that particular specific async task method to do the threading, then automatically this particular specific application need to be updated or changed in the future. So it's better that you don't use it. But yes, this is how we can do the multi-threading. And hopefully in the next class I will try to build up the things about the threading for the Java multi-threading, how we can do that, how we can process it, how we can use it in our mobile application. Okay, so this is how we can do the database. Okay, whether we are using the SQLite or whether we are using the room database architecture. Now the point is, for example, if we look at our last week lecture, so we have a main activity, we have a student list, we also have a student record activity. And in that particular specific student record activity, we are looking at how we can update the information, how we can change the information. And then we have the SQL database contract. Remember that we have that particular specific contract where we define all the names of the columns that should be exactly the same wherever we are using them. And then we also have a SQLite database helper, which is helping us to create that particular, we have defined all the methods, how we are going to create the tables, how we are going to insert the tables, how we are going to read the tables, how we are going to update the tables, how we are going to delete the records in the tables. So we have written down all that particular specific queries and the methods inside the SQL database helper. And then this particular specific database helper, we have created a static object inside the main activity. And in that particular specific main activity, we all other classes, all other activities are actually accessing the SQLite database helper object, which is a static in the main activity, and performing all those methods. But what if we won't have something like we have a JSON files, or some other cloud database. So I mean, then what we need to do, we need to have same kind of the classes, one for the cloud database, one for handling the files, one for handling the JSON, and then we need to put all the things, all the objects inside the main activity. This is not a nice architecture for your mobile application to communicate with the database. We are all dependent on that particular specific main activity, and if due to some reasons that particular main activity is being deleted by the Android system to run some other applications, then what will happen? Then, because this activity class, which is not present in the foreground, it is in the activity stack, and if it is in the activity stack, then it means that this can be deleted by the Android system at any time. So this is not a nice architecture, and if that particular specific main activity is being deleted, then your whole application is going to crash. So this is not a nice architecture. So we have a MVVM design pattern: model, view, and view model. Separation of concerns: do not write all your code in the application component, which are the activities and the fragments which are interacting with the user. So UI based classes handle UI and the OS interactions, and do not own the implementation of the activity and the fragment. Okay, so they do not own the model does not own the activity and the fragment. So represent the contract between the Android OS and your application. So that is what we want trying to do. So again, so we have UI classes, activities or the fragments, buttons, layouts, text views, image views, and so on. So all these are the views. So they are remain at a separate part, separate level, or separate layer. And then under that we have a data binding that is called the view model. So whenever there is some activity which want to access the data, it will ask the view model to provide that particular specific data. Below that we have the model, and that model can access the data from the SQLite, from the room database, from the files, or from the JSON. And they are going to the user interface or the activities can request to the view model. View model pass on that request to the data model or and access, and then this data model access is based on whatever that logic or the business logic that we have implemented, whether this particular specific request is going to be fetch the data from the cloud or from the local database or from a file, from a JSON. It will do that background data access and return back the information to the view model, and the view model provide those information to the user interface. So this is the MVVM: model, view, and then in between we have a view model, MVVM. Okay, so that is the architecture that will separate the database access concerns. Now this activity class, if that is being, due to some reason operating system decide to delete it, then we have the data bindings and everything inside our, what you can say, that the view model, which is not part of the activity life cycle. So it will still there, and it can serve the other applications, other activities, other UI components without any hindrance, without any interruption of the data access. So that is our MVVM or model view model. Okay, so that will provide us a uniform access, and it also separate the concerns: UI, US, all the UI components, user interfaces, or the user experiences are implemented at the view level. They don't need to worry about how they are going to be accessed the data. So data can come from the room database or the SQLite. That data can come from the cloud. Data can come from a file. Data can come from a JSON. So whatever that is, the at this level they don't need to worry about it. Okay, and at this level again it will a bridge between the user interface and the data itself. So again they are responsible. So this is a separation of concern in the three different layers, and that will help us to implement the information. We can change that data model at without changing this. If we don't change the view model and we change that whole data model, then user don't need to worry about it, user don't need to know about it. The reason is that we are using local database, then we can remove that total, ditch that, or remove that local database and start providing the data from the cloud. We only need to change the data model. We don't need to change the view model. We don't need to change the view itself. So that will also separate all those things. We can change in the view without changing anything below, or we can change the data model without changing the views and so on. So that will make the things and the manageability of the software or the mobile application more manageable. So next we will be, this is a just gentle introduction about the MVVM, how we are going to implement that will going to be covered in the next lecture or in the next week. So here are some references for the today's lecture. Thank you very much. Bye.